Hello, I'm ETarte, math teacher. This is the sixth in a series of videos in which I show you a portion of a tutoring session that I had with 5th grader math student Nick. A session in which I encouraged Nick to think outside his normal mathematical box. If you would like, you could pause the video and get a sheet of paper and a pencil and participate in the video by doing some writing of your own. Do you have any topic in math at school that we need to spend time on?
Not really.
Okay, well, you said a couple of things in the last lesson that interested me and got me thinking. One thing you said that even really big numbers, we can express them using just a limited supply of numerals.
Yeah.
And you named the numerals. What numerals did you name? Starting with 0 and then 1 and
0, 2, 4, 6, 8.
Well, those are the even ones.
Oh, you want the odd?
All of them. All of the numerals that we use.
Only all the numerals that we use in our letters or in our number system.
Yes.
There's only 9 of them.
And what are they?
Or 10.
There are actually
0,
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 9.
Right.
There's no 10.
That's right. When we get to 10, we start recycling them, don't we?
Yeah, because we use 1 and 0.
Right. That's because our number system is based on place values.
From 1 to 9. Or from 0 to 9.
What's our first place value?
Before the decimal?
To the left of a decimal point. Right there.
That would be the ones place.
Right. And to the left of it, what do we have? What place?
The tens.
Yes. And to the left of that?
Hundreds.
Right. Are you aware that we multiply each place name by 10 to get the next one?
Yes.
1 times 10 is 10. So our
10 times 10 is 100.
Ours is called a decimal system, and the word decimal comes from a word decem that means 10. Now the other thing you said, though, you said that your brother Kirby builds computers.
Yes.
Are you aware that computers deal with numbers constantly, but they don't use a base 10 way of expressing numbers? They use a different system.
They can use any number, really.
No. Computers use a system that's not based on 10s, but it's based on 2s. And it's called a binary system. And the BI means 2, as in the word, what's a two-wheeled means of transportation called? Starting with bi.
Bicycle.
Yes. Bi means 2.
There's also a Olympic sport. It was called the biathlon.
Okay.
It's where you ski 4 miles and you shoot, and that's 2 things.
2 things, yes.
So it would be a biathlon.
Okay.
Bi means 2.
Well, I've got a system here for the binary system. And over here we'll have the decimal system, which is our normal system. I had prepared for Nick a paper that looked like this, and the paper that I showed him, similar to this, is what he did his written work on during this tutoring session. In the binary system we have a ones place, same as in the decimal system. So I write ones there. But to the left of it, we don't have a tens place. Do you have any idea what place this is going to be instead of the tens place?
Hundreds.
Nope, it's going to be the twos place because this is based on twos.
And then you just keep on going 3s, 4s, 5s.
No, you multiply by 2 each time to get the next one instead of multiplying by 10.
Well, that's pretty easy.
So what will the next place be?
The 4s.
That's right. Can you write 4 the way I wrote 2?
Mm-hmm.
Spell it out. Okay, what will the next place to the left of that be?
8.
That's right. And these go on indefinitely, but we'll go just a little bit further. What will the next one be?
16.
That's right. Start high so you'll have room enough to write 16. Okay, I don't know if we need to do one more.
I know all of them.
What is the next one?
32.
That's right.
And then 64.
That's right.
And then I know what it is next. It's 128.
That's right. Wow. I'm impressed. Okay, well, if we need more, we'll get them.
Yeah, I know all of them.
Great. Now, do you know what numerals we will use in this binary system?
2.
We won't even use a 2 because it's based on 2s. As in our decimal system, we don't have a separate numeral for 10 because it's based on 10s.
Wow.
So we use numerals only smaller than 10.
All right.
In this system, we will use numerals only smaller than 2.
Well, so can we go before, or can we go after the decimal?
No, we're only going to talk about whole numbers.
So we're not going.
Today we're going to talk only about whole numbers.
So 1.
So
1.
Yes, and 0.
Yes.
That's right. I'm going to write this.
I was going to say 1.5, but since we were only doing whole numbers.
Right. The only numerals we will use here and these are the only numerals that a computer will use also.
Yes.
Are 0 and 1.
Well, computer is smarter than any human brain. Technically.
I don't know about that because humans invented computers. It seems to me the inventor would be smarter than what he invented. However, we can discuss that some other time.
All right.
So I want to give an example. My guess is that you are either 10 or 11 years old. Which?
10.
Okay. So I write the decimal number 10.
Mm-hmm. Actually worth 1/10.
Now, how would we express this value 10 using some of these, one or more of these binary place values, and where all we can use is a 0 and a 1?
1 times 10.
Look at the place values. You've got the 128th place, 64's place, 32nd place. These various place values. What place values can we use to
create 10?
What?
Create 10.
We don't have a tens place. We have to use the places that are available to us.
The 2's place.
Well, that can be part of it.
Mm-hmm.
Let's go from left to right, can we use this the 128th place? No, it's way too big.
It's bigger. So we should just eliminate these until you get down to
right. So what's
10.
what's the first one that's not too big as I move to the right?
8.
That's right. So we'll use the 8. What will we write there?
8.
No, all we can use. Look at the sentence. Read the sentence.
The only numerals will be used here are 0 and 1.
That's right.
So
you got your choice. You can put a 0 there or a 1 there.
0.
No, but don't we want to use this? Don't we want to use 8 as part of the 10?
Yes.
Well, then we better put a 1 there. The 1 means one of these.
1 8.
It means 1 8.
And
okay. So that's part of the 10.
I got it.
What?
Now I know how to do it.
No. Stay on this line. We'll get this line is for another number that we'll use later.
Oh.
We're only on the first line. Now you put a 1 there. Did you intend that? How much is that if you put a 1 there and a 1 there?
9.
Okay.
I was gonna.
Well, we want 10 instead of 9.
Yeah, I was trying to put it under the decimal point.
Oh.
Or we can do 8 and 1 2, but
Yeah.
the only numbers would be 0 and 1.
That's right. You can put a 1 in the 2's place, and that 1 will mean 2.
Which would.
Okay.
10.
Do those ones do what they mean? Total 10. Okay, that's right. Well, we're going to have to put something here and something here. What do you think we should put?
Zeros
Yes.
to fill it.
That's right.
Because usually, if there's not a specific number to fill in the spot, it's usually a 0.
That's
because
right.
Because a 0 is known as a placeholder.
That's correct, and that's what it's used for here also. Okay. Well, we've done your age. Now let's take a major leap forward and take my age.
All right.
Which is 79. I'll bet that with appropriate effort you can figure out how to express 79 here, paying attention to these place values and putting 1s where needed.
All right. Well,
and put it on the second line because we're doing a new number.
One, 64.
You're right. That's the first one as you move to the right.
We can't have a 32
Why is
because
that?
that would go over your limit.
That's right. It'll be over. It'll be too much. And by the way, it's worth figuring out how much is left.
15 left.
15 left. That's right.
Whoa. So that would even mean that 16 would be too big.
That's right. We can't use 16 either.
But we can use 8.
Yes, we can. So use it before you do that.
Yeah.
Use the 8. What are you going to put in the 8th place?
1.
That's right.
That would mean that we have 7 left.
Yes.
And then...
So look at your place values now and decide.
Wait, that's easy.
Oh, okay.
Now it is because you would use a 4
Yes.
plus a 2 plus 1
That's
and
right.
you would get 7.
Yes, that's right.
So do we 4, a 2, and a 1.
Yes.
And then you fill these with zeros.
That's correct. That's right. So there is, so in the binary system, this means 79.
Mm-hmm.
If a computer needs to do something with the number 79, this is the computer's understanding of it.
Wow.
Well, let's try another example of changing a decimal number to a binary number.
You want to do 32?
Okay, write 32 there. Let's see if you picked a hard one or an easy one.
Oh, I picked an easy one.
Show me.
A real easy one.
That's right, that's 32. Because there's a 32's place, that's what makes it easy. Okay, now I'll pick one. What is this year?
2014.
Okay, well, let's just take the 14. Write 14 there. That's correct. 1110. Do you think there might be some other binary way to write the value 14 instead of this, or is this the only way it can be written in binary form?
It really could be written a different way.
Can you find another way? Would you start somewhere else instead of the 8th place, or do you have to start with the 8th place?
No, you don't have to start with the 8th place.
Well, where could you start?
You could start anywhere.
Could you start with the 16th place to get a value of 14?
Oh, well, I mean, like, anywhere that's below these. Like, it doesn't matter if you do 1-4 first, or 1-8 first, or 1-2 first, because the numbers would still equal the same.
My question, though, is there some other way of writing instead of 1110 in the binary system that will have the value of 14?
Mm-mm.
That's right. This is the only way. And that's true for each of these. Each of these gives us, you have found the only way to express each of these numbers in the binary system. Okay, I'm going to make up another one. It's not going to be as easy as you.
Is this advanced for our grade? Because I haven't learned this before.
Pardon me?
Is this advanced for our grade? Because I haven't learned this before.
Yes, it is. The number of days in a year.
365.
Okay, that's in a normal year, not a leap year.
Yeah.
Try it. Now, let me give you some assistance. You need to consider whether you may need the next
Another
place
column.
value.
Yeah.
You know what the next one is?
It's 128 and times 2. That would be I don't know.
Okay, and I don't require that you spell it out. You can write it as intervals if you want to.
All right. So
Do we need that?
Yeah. 256.
Yes.
I don't know if we can go no. We can't do that.
Can't do what?
128.
It'll be too much?
Yeah.
That's right.
So
Do you feel the need of knowing exactly how much are left?
yeah. So
Oh, thank you.
256 plus 64. 6 and 6 is 12. And 2 is 3. And then 365 minus 3, 20. You would have. Oh, I put the 64 in the upper column.
Oh, wait. Let me see that. No, that's part of the 101. You already did that.
Oh.
Let me draw a line here.
Hey, come up and show up for me. All right, thank you. And I had 164.
That's not the 64th place.
Oh, that's 128th
place.
place. 1 over 164, and then 3. Minus 8. It's going to be 4, I think. Wait, no, 5. It's 5. 1, 4, and 1.
Let me see if that's right. See if I agree with you. 256 plus 64 plus 32 plus 8 and 4 plus 13. 31, 12, 15, 16. Yes, that's correct. It's amazing. You can show Kirby what you learned today and ask him if how familiar he is with this, since he's into computers. I would enjoy seeing it.
All right, well, thank you for coming over, Mr. Tarte.
You're welcome.
Appreciate it.
How do you think Nick responded to this challenge? I think he responded beautifully. To all of you, thank you for watching.